All right, so buckle up, everyone. We're diving deep today, and I mean deep into the amplituhedron. Yeah, you heard that right, the amplituhedron.
Sounds intimidating, I know.
It does kind of have that ring to it, doesn't it?
Yeah.
But really, it's just a geometric shape.
A shape with some mind-blowing implications for how we understand the universe.
Yeah, we're talking potentially rewriting the rules of physics here, folks.
Oh,
We're talking about a tool that just could, replace our whole understanding of space and time.
no, hold on just a second. Let's not get ahead of ourselves.
Right. Got to walk before we can run. But hey, the possibility's there, and that's what makes this so exciting.
Absolutely. But to get why this amplituhedron is such a big deal, we need to start with what we already know, with how we currently picture the universe at its smallest level.
Talking particles, right?
Yeah.
The building blocks of everything.
Exactly. And for decades, the go-to tool for visualizing how particles interact has been Feynman diagrams.
Those little diagrams you see, with lines and squiggles representing different particles,
Yeah, those. They've been incredibly useful, but there's a catch.
they can get really messy.
Especially when you're dealing with complex events like what's happening at the Large Hadron Collider. You have all these particles smashing together at crazy high speeds, and the number of possible interactions explodes.
So you need tons and tons of Feynman diagrams to describe all those interactions.
And each diagram translates into a complex mathematical equation. We're talking thousands of integrals, even for relatively simple processes. You can imagine how quickly that becomes a nightmare.
Okay, so Feynman diagrams, good for basic stuff, not so great when things get really complicated.
Enter the amplituhedron.
Our hero.
Well, maybe not a hero in the traditional sense. It's more like a shortcut, a more elegant way of looking at these interactions.
So instead of having to draw out a million Feynman diagrams and do all those crazy calculations,
The amplituhedron lets you represent the entire interaction as a single point on a multidimensional shape.
okay, gotta admit, picturing a multidimensional shape hurts my brain a little.
Fair enough. But the point is, each point on this shape encodes information about a specific particle interaction. And the beauty of it is, calculating the probability of that interaction becomes a whole lot simpler.
So it's like a map. Instead of having to explore every single nook and cranny individually, you can just look at the map and see the whole landscape at once.
That's a great analogy.
But here's where things get really trippy, right? This shape, this amplituhedron,
Yeah.
it doesn't exist in space or time as we understand it.
It exists in a completely different kind of mathematical space.
So it's not like a physical object you could hold in your hand.
Not at all. It's purely mathematical.
But that leads to some really wild ideas. I mean, if this shape is describing particle interactions without needing space and time,
Some physicists have started to wonder if the amplituhedron itself is more fundamental than space and time.
like what if space and time as we experience them are just emergent properties?
Yeah.
And the underlying reality is this crazy geometric shape.
It's definitely a thought-provoking concept. But before we throw out our clocks and maps, it's important to remember.
We've been down this road before.
Exactly. Quantum mechanics, which governs the world of the very small, has been using abstract mathematical spaces for a long time.
And we haven't stopped experiencing reality just because quantum mechanics is weird?
Precisely. So, while the amplituhedron raises some profound questions, it's too early to say whether it actually replaces our understanding of space and time.
So right now, it's more of a tool, a really, really powerful tool.
A tool that could lead to breakthroughs in our understanding of the universe, but whether it's a window into a deeper, more fundamental reality, well, the jury's still out on that.
And I guess that's part of what makes this whole thing so exciting. There's still so much we don't know.
Yeah, there's a lot to explore.
Now, one thing I find interesting is that initially, this amplituhedron mostly worked with supersymmetric theories.
Ah, yes, supersymmetry.
But those theories are kind of hypothetical, right? They're beautiful mathematically, but they don't quite describe the particles we actually observe in the real world.
That's right. The early versions of the amplituhedron were mainly applied to simplified theoretical models.
But I understand there's been some progress in applying it to more realistic models.
There has. Researchers have started to incorporate more realistic particles, like pions, which are essential for understanding the strong nuclear force.
So the amplituhedron is getting closer to describing the universe as we actually see it.
It's moving in that direction.
Now, what about gravity? I mean, if we're talking about a theory that potentially replaces space and time, surely it needs to include gravity, right?
Absolutely. Gravity is a major hurdle for any theory aiming to redefine our understanding of space-time.
And where does the Amplituhedron stand on that?
It's still a work in progress. There are some promising avenues of research, but incorporating gravity into the Amplituhedron framework is a major challenge.
So to sum up, we've got this amazing mathematical tool, this Amplituhedron, that simplifies complex physics, maybe even hints at deeper structures of reality.
But it's still under development. There's a lot we still don't know.
A lot to explore. And here's a thought to leave you with. If the Amplituhedron can describe properties like locality, the idea that particles need to be close to each other to interact, without relying on space and time as we know them.
What does that tell us about the nature of locality itself?
Is it truly a fundamental principle of the universe?
Or is it, like space and time, something that emerges from a deeper level of reality?
A level that we might just be starting to glimpse through the lens of this Amplituhedron. Something to ponder, isn't it?
Indeed.